Okay, very good morning to all of you. Welcome to lecture. Today we are going to start a module. Okay, very good morning to all of you. Today we are going to start a new module, that is your module number 4, microgrids and distributed energy resources. So under this head we are going to talk about concept of microgrid, need and applications of microgrid, formation of microgrid, issues of interconnection, protection and control of microgrids, review of fundamentals and integration of renewable energy sources, storage like battery, pumped hydro, microgrid and smart grid comparison. So that we are going to cover under this module. So let us begin with microgrid. So whenever we say microgrid, so obvious question is that what is a microgrid or what we mean by the grid. We have knowledge about the grid, we know what we mean by the grid. So here what exactly we mean by a microgrid, that is the question. So you can think a microgrid as a local energy grid, and when we are calling it as local energy grid, so of course this grid must have the control capability, which means basically it can be connected and disconnected from the conventional grid or the traditional grid. The other feature it should have, that is it must have capability of operating autonomously, means independently it should be operated. We can say a microgrid is a self-sufficient energy system which is going to serve in a discrete geographic footprint. Just you can imagine your college campus, you can think about a hospital complex, you can think about a business center or something like that, or you can say neighborhood. So basically the microgrid will be having a self-sufficient energy system, so it is going to supply power, and the same grid can be connected to the traditional grid or the grid what we usually talk about. So within microgrid there could be one or more kind of distributed energy system, like you can think about solar panels, you can think about wind turbines, combined heat and power generator, that is called as CHP, so which produces power basically. So microgrid is also allowing the use of distributed energy resources. In addition to these resources, many newer microgrid they also use or allow to use energy storage system like batteries, you can say, particularly typically you can think about the batteries that can be also considered as a part of microgrid. Some of microgrid also allow to use electric vehicle charging station as a part of microgrid. So basically it is supplying the electricity to that apart from a residential complex. In addition to that you will be having, if suppose a charging station, so charging station is supplied power by the microgrid. That is a possibility. Interconnected to nearby buildings, the microgrid is going to provide electricity and possibly heat and cooling for its customers, delivered via sophisticated software and control system. So basically it would be consisting of some software and control system, so that at the same time electricity as well as the heat that can be also made available. You could see one picture here which is showing a microgrid which is based on solar, and this is in US basically. So this picture is made available by the Schneider Electric. So you could see it will be having the capability to supply to nearby, you can say, residential complex or your college institute, which is having complete capability. Okay, it can microgrid that can be considered as an integrated energy system which will be consisting of interconnected load are interconnected, and distributed energy sources which can operate connected to the grid are in an intentional island mode. So there are two modes possible. One is with connection mode, with grid connected mode, and the second one, if suppose there is some fault or something, so it can also supply the electricity, heat, power to the consumer in islanded mode. So what is basically objective of microgrid? We can consider objective of microgrid is to increase or improve energy reliability. It is going to ensure better energy reliability, better security, and of course efficiency. So this is the objective of a microgrid. There is a new breed of microgrid is now becoming basically new breed of microgrid is now becoming a reality for utilities wishing to integrate local generation. The objective of microgrid is to integrate local generation. We are continuously talking about the rooftop solar or the solar generation, wind generation. Okay, so that can be integrated into system, and also it can be utilized locally. So it integrate local generation are implementing grid relief solution in area that are poorly served by the transmission grid. Still there are certain area where the transmission network is not that robust or its availability is very minimal, so a few number of consumers are get connected with that the supply, basically they are served. So in that area it basically served the purpose of supplying electricity. Microgrid, they may be a quick alternative to the building or reinforcement of transmission lines. There are certain challenges for utilities to guarantee grid reliability, stability, security, and also to optimize energy efficiency. So some of the challenges that might be served with the help of the microgrid, which can operate with traditional grid. If we talk about the characteristics, so broadly we can say the microgrid is defined by three key characteristics. That is, the first thing, microgrid is local. It is not global. It is local. It is independent and intelligent. Okay, so three characteristics are that. Let us discuss about one by one. So first characteristic, that is microgrid is local. So this is a form of local energy, which means it creates energy for nearby customers. Okay, that is for a residential complex, you could say, for a hospital, it is supplying the energy. So that particularly a grid, you can think, dedicated for that particular local consumers or customers. This basically distinguishes microgrid from the kind of large centralized grid that have provided most of our electricity for the last century. So it is but obvious that it is going to differentiate from a traditional grid. It is supplying locally, local consumer is supplied by this. Central grid push electricity from power plant over long distance via transmission and distribution line, whereas it is a local, so local distribution will be there. So delivering power from afar is inefficient because some of the electricity as much as 8 to 15% dissipate in transmit. We know that when we are using the traditional grid or the power grid, there are losses. Certain losses occurs in the transmission line. So when we are talking about a local grid, that is microgrid, so in that case that losses can be minimized. That's why we said the microgrid is ensuring the energy efficiency. It must ensure high energy efficiency. So that basically makes it more efficient. A microgrid overcome this inefficiency by generating power close to those it serves, means at near the load center you are producing the power and supplying it. Usually the load center and the generating center that is far away from the load center in conventional plant, which we know very well. So the generators are nearer within the building, or in the case of solar panels you can say it is on the roof. So on the rooftop you are having solar panel, so from there you are getting the supply. You are having a local grid which is having capability to deliver that energy to the nearby consumers or customers. The second, microgrid is independent. It means what? It means that microgrid, it can be disconnected from the central grid and it can operate independently. Means the microgrid is connected with the main grid. It operates along with the main grid by connecting it. So when it operates independently, we are saying that it is in islanded mode. So this islanding capability is basically enabling microgrid to supply power to their customer whenever there is some fault or there is not a supply from the supply availability is not available from main grid. There could be another situation when there is a storm or there is a calamity which causes outage in the main power grid due to n number of reasons. There is outage of generator, there might be the transmission line, there is a fault on a transmission line, or something, anything could be there. So in that time the microgrid in islanded mode, it is going to supply the electricity. If we particularly take example of US, so there the central grid that is especially prone to outages because of their sheer size and interconnectedness. More than 5.7 million miles of transmission and distribution line is there. So basically if there is some fault, so some of the consumer, they may not get the supply. If microgrid is there, so locally it can be supplied because it can work independently. You can isolate it, island it. There is an example in the US that is a very well known example, Northeast blackout, which occurs in 2003. There was a single tree which falls on a power line and which knock out power in several states. See, only one tree which falls on a transmission line and there was complete blackout. So if there is a microgrid, it can operate in islanded mode. So such type of, you can say, event, during such event, at least the customer to that area can be served by the microgrid. So this is an example. You could now appreciate how the microgrid is going to maintain the supply by operating in islanded mode during some event like what we have seen. If there is complete blackout, so those area will be supplied, and we know that certain customers require continuous supply, so that can be maintained. Like hospitals, they require 24/7 supply. While microgrid can run independently, most of the time they do not, unless they are located in a remote area where there is no central grid or an unreliable one. It means it has capability of running in islanded mode. It do not run in islanded mode. They run in integrated mode, that is they are connected with the main grid. So a microgrid, it is connected with the main grid. So this is connected most of time, unless and until there is requirement. It remain connected to the central grid. If there is any abnormal condition, it can operate in islanded mode or in independent mode. So this is the characteristic which is defining, okay, if this capability of a grid is having, local grid is having, we can call it as microgrid. The third point we said, the key characteristic, that is it is intelligent. Microgrid is intelligent. Why we are calling it as intelligent? Because it is having advanced system. So this intelligence emanates from what is known as a microgrid controller, the central brain of the system, you could call it as. So this central brain, or the brain of microgrid, that is going to manage generators. It is, if it is a solar rooftop and you are using the batteries for storing the power, so it is going to manage batteries, as well as it is going to manage nearby building energy system. The controller orchestras multiple resources to meet the energy goals established by the microgrid's customers. So there could be multiple energy resources, so it is going to manage those multiple resources as well. It tries to achieve lowest price. See, the important thing is there when we are talking about the microgrid and you are having access to main grid. So the main benefit would be at that time achieved if you are getting electricity at a lowest price. Other aim could be a clean energy. You can use solar, wind in order to get the clean form of energy. Reliability, highest reliability, of course, if microgrid is there, so it must provide the reliability, and some other outcome. The controller achieves these goals by increasing or decreasing use of any of the microgrid resources. So there are certain goals how it can be met, because there is a brain, there is some intelligence with the microgrid. So it is going to optimize things in such a way so that the goal can be achieved. Whatever objective we are having, that can be achieved. Let us consider one example. A software based system is there. So the controller that can manage energy supply in a different way. The advanced controller, basically it has capability to track real-time changes in the power prices. We talked about home energy system. We have seen, consider the example if there is dynamic pricing and pricing is changing. Whenever the price, there is change in the price. So accordingly, the consumption or the utilization of home appliances that can vary. So that can be done with the help of some advanced software based system or energy management system could be utilized. Okay, so this example already we have seen, so that we are talking here only. There are certain more characteristic if that follows, so we can say, okay, this particular local grid can be considered as microgrid. So what are those characteristics? It includes if it provides sufficient and continuous energy to a significant portion of the internal demand. Significant internal means maximum portion of the demand that must be met by the local grid, local energy sources, though it operates in interconnected mode with main grid, but it must be capable of supplying most of you could consider 80% or 75% of load that should be met locally, and remaining 30% that can be taken by the main grid. Another characteristic could be it has its own internal control and optimization strategy. What it means that you are having a number of sources, energy sources, distributed energy resources you are having. So how it has to be utilized, its capability, the controlling capability should be there. optimization strategy. Why optimization? Because you are having certain resources, and if you are not fully utilizing it, instead of fully utilizing it, you are drawing power from the main grid, then there is no worth. So it should have its own control and optimization strategy. If it is there, so we can call, okay, this local grid is basically a microgrid. Other characteristic of that local grid should be it can be operate in islanded mode. Means once you have disconnected from the main grid, it must be able to supply local consumer. And later on, if required, it must be reconnected to the, whenever there is a need, it must be reconnected to the main grid. So that capability should be there, so that there should be minimal service disruption. It can be used as a flexible control entity to provide services, optimization for the grid or the energy market. So flexible control entity, flexibility basically, it is going to help the main grid as well as, you could say, the energy market. The other characteristic that could be applicable to various voltage levels, it can have storage capacity. Like if solar is there, so we know the characteristic of solar and wind, that the power is available at certain period of time. So it is not necessary that whatever you are producing, that you are consuming at the same time. So the excess or surplus electricity that can be stored to the storage facility. So it must have storage capacity. So these are the certain characteristics which basically defines a microgrid. So you could see that the same is pictorially we are presenting here. Am I disconnected? Okay, yeah, it is little slow. So you could see that a microgrid controller is there. So it is connected with main grid utility, you could say, via the transmission line. There could be the renewable energy sources like the solar photovoltaic cells, rooftop could be there. There could be the wind turbine, there could be energy storage system, there could be some generators that can be also integrated, the combined heat and power CHP stations that can be integrated to the microgrid. Then there is EV charging stations, EV charger, basically the load residential consumers which is having the solar rooftop generation, you could see that. Then there could be a commercial load, there could be some organization, commercial organization, institution. So this could be a microgrid. From this picture you could understand what we were discussing about. So microgrid, they may contain energy resources, CHP, wind power, reciprocating engine generators, fuel cells, that is so basically when everything is added to the local grid and the microgrid, so its complexity that is going to increase basically. So we talked about what we mean by the microgrid, but sometimes often we confuse with what a microgrid is not. So let us talk about that. So some people use the term to describe a simple distributed energy system such as solar rooftop panel as a microgrid, which is not basically a microgrid. There is a difference. A microgrid will keep the power flowing when the central grid fails. This is an important term because microgrid has capability to operate in islanded mode, but it most of the time, unless and until there is certain failure, it does not operate in islanded mode. Failure means what? There is interruption in supply from the main grid, and there is possibility that it is provide some support to the grid. If suppose there is a fault or there is excess load, So at that time this microgrid is drawing some power, so it can be operate in islanded modes. So this is a possible case, we can say. It is not necessarily this would be the case, there may be some other case. So a microgrid will keep the power flowing when the central grid fails. That is the difference. A solar panel alone will not do that. Many homeowners with solar panel are unaware of this fact and are surprised that they lose power during a grid outage. Simple backup generators, they are also not a microgrid. You are having some DC generator set, so you cannot call that as a microgrid. When there is certain emergency, at that time only we brought that generation, like the DC generation or some battery you are having, battery storage you are having, so that comes into the picture for supplying or meeting the emergency loads, demand for emergency loads. Microgrid is going to operate 24/7 by 365, managing and supply energy to their customers. So this basically gives a clear idea what is not a microgrid. Already we have seen certain characteristic which indicates that what is microgrid. That's why we talked about the characteristic. One micro turbine in a commercial building, that is only DG you can say. A group of individual generation sources that are not coordinated but run optimally for a narrowly defined load. A load or group of load that cannot be easily separated from the grid or controller, that is not microgrid. So what exactly the microgrid? We can say a microgrid's capacity to self-manage and define operational strategy. We said it must have some controlling strategy. So operational strategy concerning islanding mode and self-reorganization makes it the ultimate smart grid offering. So it has self-management capability and it has operational strategies, particularly when it is operated in islanded mode, you can see, and self-reorganization capability. So this basically microgrid's feature is going to make a smart grid, ultimate smart grid, what we are talking about. We can come across a formal definition because you'll find out a number of definitions. So what we could call a microgrid formally: a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries. A boundary is defined, under that whatever number of resources, distributed energy resources are there, the loads which are connected to this, within this boundary, we can, and there will be some controllable entity, basically single controllable entity with respect to grid, you can say that is microgrid. The other thing, the microgrid can connect and disconnect from the grid to enable them to operate in both connected or islanded mode. So this way you can define the microgrid. See, in this picture, purposely a switch is shown for better understanding. There would be not this kind of switch, but for increasing our understanding, a switch is shown. So basically it can connect with the main grid, this microgrid, and it can disconnect with the main grid. There can be connection with other microgrids also. Possibly you might have two separate microgrid. One is in your institute, the other maybe nearby hospital or industry might have their own microgrid. Okay, so this is showing you formally, you can see formal definition you could call for a microgrid. Here this particular picture is giving you a glance, basically the energy flow in a microgrid, you could see that there is CHP, there is generator set, heat exchanger, on-site biofuels is there, there is some thermal energy storage, then there is electrical energy storage, it could be stationary electric vehicles, then there is choice of on-site energy sources, PV, heat pump, solar heat, wind power, then there is end-use equipment which requires, maybe there are some applications where the electricity is required only for certain application. Refrigeration and building and cooling could be there, hot water may be needed, there could be building heating is requirement, there may be the requirement of gas, liquid fuels. So this complete thing is basically your microgrid. Here you could see that, and here what the flow of energy, what is flowing, the different energy is there, there is fuel, there is electricity, there may be certain losses into the system, so that flow is shown with by the different color. You could observe it and you might understand. There are certain passive measures also, heat is there, so how it is flowing from utility interconnection to the consumers or the end use equipment. So from where you are getting the energy, certain energy might be purchased, some energy is basically locally generated. Okay, when it is connected with the grid, it means you are purchasing electricity. So there could be, depending upon the number of fuels or the requirement, it could be gas, it could be electricity, it could be heat in the form of heat. So it can be purchased from various places, as well as this microgrid, if it is having the surplus electricity, it can sell that surplus electricity to the grid. So that is also a feature which I think we have missed somewhere. We are drawing power, we can draw the power from the main grid, as well as if there is surplus, it can store locally, and even if there is more surplus, it can sell to the grid. So this can be some monetary benefit can be obtained through this. There is an obvious question that how does a microgrid connect to the main grid? So it can be connected at a point of common coupling that maintains voltage at the same level as the main grid, unless there is some sort of the problem on the grid. So voltage that should be same basically, or other reason to disconnect. A switch can separate the microgrid from the main grid automatically or manually, and it then function as an island. Being electrical engineer, we know that there could not be a normal switch. Just for our understanding, we have mentioned here that a switch can serve the purpose. Let us talk about the microgrid drivers. So this includes the environmental incentives, cost-effective access to electricity, reliability, security, energy efficiency. These are the goals basically which need to be achieved. There is possibility of renewable energy implementation. So in order to achieve these goals, basically this become the drivers. We are interested in high reliability. There should not be disruption or interruption of supply for a single minute. That means reliability is required. Energy efficiency, significant losses is occurring at various stages. So interested to reduce those losses. Once the losses, we are capable to reduce the losses, we are capable to increase the efficiency. So that is the aim. So these are the drivers basically. Environmental incentives, when you are going with renewable energies. So more and more electricity from renewable, if we are capable to utilize it, and microgrid is helping it. It means what exactly you are doing? You are stop using electricity from a generation which are producing the greenhouse gases. So ultimately there is reduction in GHG gases, because more and more electricity is made available to consumers from renewable sources. So ultimately it is going to support the environment. So environmental incentives can be obtained. Cost effective access to electricity. Microgrid that constitutes a relatively cheap and efficient step toward rural electrification. Transmission line is needed. There is a huge investment in to set up a transmission line and construct the transmission line. So investment is involved. In rural area, you go with a microgrid. So no need of huge investment basically. A robust infrastructure that is not needed. Reliability, of course, it is going to, that is a driver. We need more reliability. Security, the islanding capacity of microgrid that improve the grid resilience. There are certain cases which are difficulties, you can say, which is not known to us or which is unforeseen, you can say. So there is an important factor for several sensitive and consumers. You can think about hospitals, you can think about military bases where electricity is needed. There could be the server farms. Energy efficiency, so yes, we are capable to reduce the losses by transmission losses, particularly because we are transmitting power over long transmission line. So that can be basically reduces renewable energy implementation. We already talked about there are certain goals which has to be achieved by various countries. Targets are there in order to reduce the GHG gases. There is development of electric vehicle which can be seen particularly as plug and play storage capacity. We already talked about that. If there is need of power, so it can be supplied through electric vehicle. This plug and play capacity is there, and the energy can be stored to the batteries of electric vehicle by just connecting to the thing. So basically these are having a large impact on microgrid development and research in the coming year. Because of these goals, what we talked about, renewable energy integration, energy efficiency, reliability, security. So there will be more research in the upcoming years in future. Now let us talk about the microgrid benefits. Microgrid is allowing to integrate renewable energy so that it can consume locally. Microgrid must reduce electrical losses, increase grid stability and security. So in a combined package, we can say it is ultimately going to reduce the cost of electricity and spending. You can say it reduces spending for consumer as well as the distribution system operators. We know that who is delivering electricity at the consumer end. It is a distribution company. We often call it as Mahavitran in case of Maharashtra. So distribution system operator, its burden is going to be reduced in terms of economics, you can say. So broadly, if we talk about the microgrid, will be having the benefits can be divided into three categories. One will be the economic benefit, another one will be environmental benefit, and the next one will be the technical benefit. So this benefit, basically economic, environmental and technical benefit, this benefit, who will be the beneficiary basically for this benefit? So this will be your consumer. The beneficiary will be your distribution system operator, that is your Mahavitran in case of Maharashtra, and micro generation as well. So whatever is the benefit of micro generation, that will be also considered as a benefit of microgrid. So micro generation, that is also going to get benefited. So let us see this, what are these benefits one by one. So let us talk about the economic benefit. So in economic benefit, you could see here there is a load consumer benefit, there will be the micro generation benefit, and the network spending reduction will be there. So who is going to benefit? The load consumer benefit, of course, this will be benefited to the consumer. A micro generation benefit, it will be benefited to the micro generation, that is a beneficiary. And the network spending, that because the distribution system operator have to expand the network in order to supply to a consumer which is at a remote place. There might be only a single consumer which is far away from their last distribution line, so they need to expand it. The distribution network might be there, maybe installation of one transformer is also needed, so that money can be saved basically. Let us see the load consumer benefits. So microgrid automation system that encompass relatively complex price setting mechanism. It is possible to imagine system in which dynamic pricing software calculates in real time the cheapest source of energy, main grid electricity and local generation. You are having consumer is having two options. One is microgrid, another one is main grid. If suppose the energy availability is from the microgrid and they are offering at a lower price, at the same time the energy supplying by the main grid, it has a higher prices, so the consumer is having a choice. It can go with microgrid supplier, the local supplier, you can call it as a local supplier, those who is handling the microgrid. So from there consumer can can procure or get the power. So this way there is a load consumer benefit. So ultimately consumer is capable to minimize its energy bill. So that feature is there. Micro generation benefits. So many countries, they have introduced incentives to accelerate the implementation of renewable energies. So these schemes include a subsidized price for the owner of a renewable energy generation system. You can think about PV, wind, small hydro, biomass. So they can sell back this to this electricity to electricity company, produced at the higher than market price. This can be also considered as a microgrid benefit. Network spending, already we talked about this. In areas where the existing infrastructure is under high demand or where there is no existing electrical infrastructure, particularly you can think about the rural areas in developing countries like in India. So microgrid implementation, that could be represent a much cheaper alternative to transmission infrastructure cost. So network spending is in that respect reduced or at a very least postponed. Environmental benefit, renewable generation is increasing, so the greenhouse gas reduction will be there. So ultimately it is going to benefit consumer as well as it is going to benefit the micro generation. Indirectly you can think it can also benefit the DSO, the distribution system operator. Think about Mahavitran. Let us talk about the technical benefits. The technical benefit would be the peak load saving. We are continuously talking about that at certain period of time the demand requirement is very high. So at that time, to meet this increased demand, inefficient units are utilized, which are having the lower efficiency, those units are utilized. Are the unit which is based on fossil fuels, diesel generator set, you can think about that. So that is utilized. So ultimately that is a costly option. So microgrid that help here to save the peak load curtail it or maybe flatten the demand. So basically the dynamic pricing, we already talked about that. It can be coupled with the availability of local generation. So it can shift the peak load, the load from peak hours to off-peak hours. Also, it is shown in a study that a dynamic saving can lessen peak load demand by 10% and general consumption by up to 15%. So it is observed in one of the study. Reliability enhancement, that would be one of the technical benefits. Due to the potential high quality local automation capacities, microgrid should improve general grid stability and electrical reliability. Voltage regulation, it is but obvious. Energy loss reduction, already we talked about that, because there is no need to transmit over a long transmission line. So these basically technical benefits, that is to you can see the reliability benefit, that will be to the consumer. Here the energy loss reduction, it is going to benefit consumer as well as the micro generation. The voltage regulation, so when there is improved voltage regulation, so it is going to help the system operator, Mahavitran. They not need to worry about the maintaining the need of the reactive power or some reactive supplying capacity, reactive controller. Basically they not need to basically it will get rid of those things, not completely, not fully, but there will be little headache for DSO if there is a microgrid. Peak load saving, it is going to benefit of course the distribution company Mahavitran, because they have to procure electricity accordingly. So peak load saving, that would be a technical benefit which will be to distribution system operator. If we talk about microgrid categories, so broadly we can say the microgrid, it could be for institutional. So you can call, there is institutional microgrid. You can think about hospital, university, military campus, commercial complex, like that. But basically the commercial complex, we can keep that in another category. So one could be your institutional microgrid, another could be your commercial or industrial microgrid, which may include your factories, commercial malls, business towers, etc. And third category could be your community grid, which may consist of multiple houses, or you can think about the apartment buildings, multi societies, and some of the commercial building that can be also included to the community grid. Another possible classification of microgrid, that can be on the basis of the voltage levels. So in this figure we have shown 4 categories. You can call it as ABCD depending upon the voltage segment. So there is LV segment, low voltage segment, medium voltage segment less than 5 megawatt, medium voltage feeder less than 20 megawatt, and primary station greater than 20 megawatt. So in this category the microgrid can be classified basically or categorized. So under LV segment there could be 1 MV load less than 2 megawatt. So it could be used for smaller individual facilities with multiple LV loads. You can think about hospital, schools, solar, wind could be supply, can be considered as the resources. It can contain a switch for islanding the microgrid. In second category, it is medium voltage segment less than 5 megawatt, smaller to large traditional CHP facilities with a few MV loads, mostly C&I, solar, wind storage could be utilized. It can also be a multi-A type microgrid. The first segment what we said, that can be multi-A type microgrid. It contains switches for islanding the microgrid. This section cut the feeder basically. The third will be your MV feeder less than 20 megawatt. Small to large traditional CHP facilities can be included. Solar, wind storage, that can be included. Many are large MV loads, it is not lakhs, loads, typically C and I, that can be included. It can also be a multi-B type microgrid. It contains the entire feeder is here included, with switches at its extremities for islanding the microgrid. Primary station greater than 20 megawatt, the fourth category. You can refer it as mini grid. Traditional CHP, biomass, large solar wind storage that can be included. Many MV loads might be there. All load types is possible with this type of grid. Up to several 10s megawatt or large industrial complex can be included. Can also be a multi-C type microgrid. Control substation with HV-MV transformer is basically required in such type of microgrids. So here we are going to stop with this microgrid categories. If you are having any question, you can ask. Otherwise, we can stop here. So in this lecture, basically we talk about what exactly we mean by the microgrid. So that we talk about.